Saw you up there.
All right.
And this was the talk about how bees survive a cold winter.
All right. You guys ready?
Sure.
Okay. Let me okay. Oh, I gotta share screen first. Hang on. Okay, share. Share. Slideshow from beginning. More. Come on. From beginning. There we go. All right. Can you guys see the full screen now?
Yes. Yep, looks good.
All right. So honeybee is an interesting organism. It's a tropical bee, essentially, that's learned to adapt to living in warm climates. So I took this picture in Hawaii, where a colony can live right out in the open, where it's warm all year round. They don't need a cavity. But when it gets cold in the winter, as it does up where you or I live, they need to, in order to maintain this elevated temperature of their body during the winter, they do so by using honey, stored honey, as an energy source. And what they do is they make a tropical or subtropical environment inside a cavity, typically a tree cavity, or in our case, a beehive. And what they move like a yo-yo. So during the summer and spring, when they're storing honey, they put the honey reserves up here and they push the brood nests down. And then during winter or during dearth, when they're eating the honey, they move back up. And if they hit the top of the cavity, they run out of food and they starve to death. So we try to avoid ever having them hit the top of the cavity. So winter management actually begins in late summer. So what you do here in late summer determines what's going to happen. And then the old adage is to take your winter losses in the fall. But first, what you want to do is make sure you control varroa early in this season. So we want to get, by September, we want varroa counts down to close to 0 in our hives. Colony like this is not going to survive the winter. You got bees with deformed wings. You got some larvae and pupae dying of deformed wing virus. This colony is walking dead. Doesn't know it, but it's not going to make it through the winter. So late summer varroa management is critical, depending on the various treatments you can use. You want to get them on, we like to get them on in mid-August prior to fall brood rearing. So you're not interrupting the fall brood rearing with your mite treatments. So before the fall brood rearing, you don't want bees looking like this. So when I look at my varroa model, where you have the total population of bees, the amount of brood, the percentage of brood here infested with mites, your total mite population, and your alcohol or detergent wash count right here. You can hit them late like this and get that level down there. But because you already got the virus level so high in the colony, it very well may not survive the winter. So you want to control by mid-August, so that here, as your last rounds of brood here, you can rear these and have healthy bees emerging to form your winter cluster, your winter bees. So what we do then, we're doing today, is we feed pollen sub. We don't have much of a fall pollen flow where we live, so we do supplemental feeding in order to encourage them to rear that healthy, well-fed last generations of brood. If we see it look like this where they don't eat them, we flip the lid upside down and walk away from them. Don't bother with anything else. It's just not going to make it through the winter. Then finally, we get our first cold frost, which kills any remaining flowers. And at that point, this is data from Manitoba, Canada, from Lloyd Harris. And where it shows here is at this point, we got the first frost and their brood rearing. So the dotted line is the amount of brood in the colony. This drops right off and they go into form their winter cluster, with these last emerging bees becoming these diutinous long-lived winter bees. And the colony weight slowly drops down, but what they do is they allow the nest temperature to start to drop down a bit. And Lloyd Harris also has these nice graphs showing that any bees that were summer bees, the blue ones here, die off pretty quickly going into winter. Very few of them live to December. As these last rounds of brood reared in September and October, that then formed the winter cluster. So when these the last round of nurse bees emerges and does not smell any eBeta-osmine, any young larval pheromone, letting them know that there's no larvae to feed, they fatten up on pollen, build up their protein reserves, and get ready to hunker down and wait until there's fresh pollen coming in, at which point they will resume brood rearing again in the spring. So this is a survival state for the honeybee. Actually, it's maybe like considered the default state for just long-lived bees that hunker down and wait for brief nectar and pollen flows to start reproducing. And you can see these are the fat bodies in the bee's abdomen here, comparing those in a forager bee to those in a winter bee or a nurse bee, the heavy fat bodies here. And this is their protein reserve going into the winter, which they do need to replenish a little bit by eating a little bit of bee bread over the winter. And we feed pollen sub in that last round of brood. When they emerge, they chow down on it. And here's a squash that I did in November with showing, this actually was natural pollen in their guts right here, filled full. Then we get the fall turnover. And at this point, all these summer bees start to die off fairly quickly. The bees that have flown during the summer. Aging of bees is largely about how much they fly. So they live a long time until they start flying. And they live for 8 to 12 days typically. So these bees die off of old age. And what we found is this data I had from years ago of 99 hives that we followed them through the season, looking at the cluster size. So these are 18 frame cluster sizes. This would be in October. The light blue would be the December strength, and the green would be the January strength. The reds are the percentage of dinks out of the each number. So these are colonies that were 18 frames in strength in October, going down to those that were down to 7 frames of strength in October. You can see the great big ones, they shrink quite a bit. They can lose a lot of that field force. What was interesting is look how the cluster size kind of equalizes no matter how big they are, how small they started. And then for January, some of them actually, the small clusters actually expanded. So this 8 to 10 frame cluster size appears to be the ideal size for colonies during the winter. And Jeffrey's research in Scotland found the same thing. He tested all kinds of different cluster sizes and found that 8 to 10 frames of bees was the ideal cluster size. So the cluster then clusters together to conserve heat. If you give a puff of smoke, oops, I don't have a picture of that, huh? I did. Let me go back up here. There's a thin mantle of bees on the outside. We'll get to that later on in here. But they want to minimize their amount of surface area that loses heat. And then instead of these bees, the last bees acting as nurses, they live for a long time. You see, there's almost no mortality of those bees during the winter till after they've begun rearing brood and the first round of brood emerges. And then at that point, these bees get pushed into foraging and die off very, very quickly. So these bees hold the fort until springtime. So Lloyd Harris also found that that any colonies converge towards a common cluster size, about 9 to 10 frames of strength in December. This is up in Canada, the bees up there. Same thing with Jeffrey and Allen, 56. They found between 7 and 10 frames. They also found that if you get too large a cluster, they can overheat or die of thirst. So too small a cluster is a problem and too large. So there's kind of an ideal cluster size here. So for fall management, first thing we do is we have them for weight. If you can pick them up with 2 fingers, tip them with 2 fingers, that's too light. We want a 3-finger lift to pick them up. In our area, we want about 130 pounds per double deep. So that'd be 65 pounds on a lift. So you can use a luggage scale if you want, hook it under a handle and pick up to see if you got your 65 pounds right there. If not, we'll do supplemental feeding to or swap combs of honey to get that weight up there. We want to go into the winter with our cluster down entirely in the bottom box with entirely honey above that cluster. So they have plenty of room to work up into that honey. And then you want to provide top insulation. Here's a bunch of singles in the spring snow, and you can see the melting snow up here and there. That's saying they're losing all their heat right here. Not only that, that means that the moisture inside the hive is condensing underneath the lid right here and raining down on the bees. So top insulation helps colonies a whole lot. That's where most of the heat loss is. Once they go broodless, we give them an oxalic dribble. You can use an oxalic vaporization. And very, very quick. The dribble right here is a second per seam of bees. So we could do this. This would be like, 13, 14 frame colony. It's 13 or 14 seconds to do it. And we just blast through them one after the other. You can do them in cold weather. Just make sure you get a dribble on each seam of bees. And this eliminates most all the mice and gives the bees a really nice start in the early spring there. And then the colonies go into dormancy. This is when we get a snow here. This is what my homemade berry looks like. We just leave them alone. Now in the winter cluster, it looks like a solid ball of bees, but if you give them a puff of smoke, you can see these bees move very quickly because they're at a warmer tropical temperature here. And you have these bees at an insulating mantle out here. They have their tail ends sticking out, and they keep that right around 50 degrees or so. Keep the thoraxes slightly warmer right there. But that's the outside temperature around a colony of bees, around that 50. If it gets really cold, they'll drop down to 45 degrees or so. Usually it's around 50 degrees right here. And you can see that these bees on the mantle, they have to overlap some honey so they get food. They need that energy source of honey. And it's not really clear exactly how much energy is transferred to those mantle bees, which are generating most of the heat. Most of the heat is generated by the bees in the mantle, the cooler bees, and the bees on the inside benefit from that mantle generated heat so that there's not so much loss of heat by conduction and convection outward. The honey around there is a very poor conductor of heat. I measured one night when it was cold here. I put probes into the honey and then right into the cluster just inside, and centigrade. There's very little difference in the temperatures, just even an inch away right here. So the honey remains cold. Bees don't try to heat the honey. They just want to heat the cluster right here. Now, in a winter colony, understand that you have an inch of honey and then about 3/8 of an inch of bees. An inch of honey, 3/8 of an inch of bees. These are, it's like sandwiches with little thin layers of bees with this warmed honey right in the middle, and then this chilled mantle out there. It's not anything solid about those bees in that cluster. Going in Canada, a lot of the guys that shed winter, they'll feed enough syrup in the fall that every single cell on every comb is solid honey. There's no drawn comb at all for the bees to stick their heads into. It's just solid honey between each one of these layers, and they winter just fine. The male bees produce a lot of heat. So if you look at the temperature here, you can see that the metabolic rate of the mantle bees is much higher than the metabolic rate of the bees in the brood nest. So even though these are at a cooler temperature, they're running at a higher metabolic rate to maintain that cool temperature. What you have is most of these mantle bees, when it gets cold, if you get down to freezing temperature, most all have their heads facing in, and about 10% are heater bees producing heat. And I don't have it on here. I've done a bunch of thermal imagery since I made this PowerPoint. I've got to put on showing that you can pick out the heater bees very, very easily. And they apparently take turns heating by flexing their wing muscles. So here's how it works. They keep their butts out towards the outside of the cluster and their heads towards the inside of the cluster. The heat's generated here in their thoracic flight muscles by doing isometric contractions. And at the petiole, they have what's called a rete mirabile, which means that your outgoing blood vessel crosses the incoming one so that heat can transfer to it. So they can keep their head and thorax warm and allow their abdomen to cool several degrees cooler than this area. So they're always pumping heat forward towards the cluster. Now, if you look at the metabolic, here's the contractions of those muscles. Once you get down to a cold enough temperature below about 50 degrees, they are unable to flex their muscles anymore, and they go into a chill coma. So when they get down around 48 degrees or so, they can no longer produce heat. So they do not allow their bodies to get that cold to avoiding going into chill coma. And what's interesting here, this is from Stabenthaler here. He's showing the temperature of the mantles of the bees and the temperature of the heads and thoraxes. So this is at 10 degrees centigrade, about 50 degrees Fahrenheit. You can see their heads and thoraxes are quite a bit warmer than their abdomens are, which are sticking out. In the core, you can see these bright colored bees. These are the ones that are producing heat in the middle of the core. And the hot bees from the core apparently go out and visit the mantle from time to time. And the mantle bees from time to time go in, allow their bodies to warm up so their enzymes can work properly and stabilize, and then they go back out to be in the mantle again. So here's another picture from Stabenthaler by showing these very, very hot thoraces right here, and then the head being warm, but the hottest temperature, looking over here, being in the mantle. So this is about brood nest temperature right here. And they can sometimes get up to 115 degrees in their mantle, especially on the smaller clusters. So if you look at your metabolic rate relative to the ambient temperature, you have the lowest metabolic rate. So this is also your lowest honey consumption, right at about 41 degrees Fahrenheit. So that's why all your shed-wintered bees are kept at 40 degrees Fahrenheit. That's the least amount of energy loss there. If you get any colder than that, energy consumption goes up. And if they get more active, they also use more energy. So the ideal temperature is around this 42 degrees Fahrenheit, 5 degrees C for wintering. A lot of concern about moisture and ventilation. I imagine up in your area with your very moist climate, this would be a big thing. So this is an interesting quote from Mibus back in 1998. It says that many of the arguments given to back up any recommendations for providing more and more top ventilation are based upon reasoned considerations or anthropomorphic thinking rather than on sharp-eyed observations of bee behavior. And I find that interesting. The bees have been doing this for a long time. So what they like is, let's take a look at what they do in their winter clusters. They like top insulation above. They varnish the inside of the cavity with propolis so that water doesn't get absorbed. It condenses there so they can take the drops of water. And they like a small entrance near the bottom of the cavity. They also like to have their food above them. So as the warm air rises, it warms this slightly, and it's easy for them to move up. Over in Europe, many beekeepers keep in their bees in single-story hives, and they have the honey to one side and the cluster near the entrance, and the cluster needs to move sideways into the honey, a little bit more difficult than moving up and down, especially if you have your combs crossways like this to the bees. So different things to think about as far as these cluster moving through those combs, those spaces. They have to move around the combs. Now, for winter feeding, if you give them excess water, they can get water imbalance in their guts, and they can get dysentery. They have too much water in the gut. They can't fly out to poop, so it builds up. So you want to avoid adding moisture if it's too cold for the bees to fly. So in those areas, you're better off feeding a sugar candy or a fondant to the bees. Now, the winter cluster is very interesting too. So here's a cross section I drew with this insulating shell, about 50, 55 degrees right here. And then you have maybe they'll bring it up to 95 degrees if they are rearing brood. Otherwise, they keep it around 65 to 85 degrees. They have lots of heater bees right around here and a few heater bees in the middle. It's pretty much airtight. The carbon dioxide content goes way up to from 30% up to 5%, enough that humans would die breathing that. And the oxygen content goes down from 21% down to about 15%. So that tells you this is airtight here. They control what's in here. It's very, very moist here because this is where the moisture from here condenses. So these bees are full of water and these bees are thirsty in the center right here. And they appear to mostly do their ventilation out of the bottom of the cluster, which allows them to recapture the heat from the heat of condensation as that water then condenses down below the cluster. You look here at the temperatures around here. You're going to have brood nest temperatures 94 degrees, but outside the outer part of the cluster, it's going to be, this is down to 17 degrees Fahrenheit right here. So you have this outer edge that just right around that 50 degrees right there, and then they let it get quite a bit cooler. They don't try to heat the entire cluster. So they do like a tight cavity with no drafts, so they can trap some of this heated air in here. And some insulation on the sides, but not too much. Too much insulation on the sides is actually a problem in the spring because they can't tell when it's starting to warm up outside and start rearing up brood rearing. Bees that live in the free wild bees in cavities, they seem to really prefer single entrances about 4.5 inches square. Just in case you didn't know, the word propolis comes from the roots pro meaning in front of and olis meaning the city, because this is the curtain of propolis in front of the city that the bees build. And a proportion of my colonies do that every year. Beekeepers tend to breed against heavy propolis production. This is very natural for bees to close off the entrance or any other cracks during the winter and provide minimal entrance ventilation during the winter. And this is a neat quote from 1907. In the matter of ventilation, bees seem to make a very determinate and highly successful stand against imposed conditions. They refuse point blank to have anything to do with human notions of ventilation. Many devices have been tried in the form of vent shafts and the like to carry off the vitiated air of the hive, but all have failed because the bees insist on stopping up every crack or crevice left in the walls, roof, or floor. For some inscrutable reason, they will have only one opening, which must serve all purposes, and the hive maker has to learn by hard-won experience. The bees are right. Well, that's clear back in 1907. We still have lots of people talking about ventilating their hives. So they seem to do well with a simple wedge to keep the mice out, about a 3/8 high by 3-inch wide entrance. Unless it gets too cold and you get dead bees piling up inside, this works fine in many areas. Now we talk about metabolic water. So a wintering colony consumes about a pound of honey a week. You have what's called metabolic moisture from going from sugar, C6H12O6 plus oxygen, turns into carbon dioxide plus 6 molecules of water. So that pound of honey produces about 6/10 of a pound of water. You add to that the 70% of moisture in honey, and you wind up with about a cup and a quarter of water produced per week in a hive by those bees. So the question is, where does that water go? some of it they needed to drink back in order to dilute the honey that they're eating. So, what I look at, if you if that colony is eating that much, they're also producing water vapor and carbon dioxide, which takes up more space, that water vapor. So they actually have every hour about a quart and a half of water vapor as air pushing out of the hive during the winter. So it's continual breathing out all winter long of that moist air going out of the hive. That's without them fanning in any way at all. That's simply by the water vapor that is produced by those bees from their metabolic rate. And then here's a picture of the carbon dioxide. This is distance from the center of the cluster. So right in the center of the cluster, carbon dioxide gets really high, and to the outside, it drops down low. And relative humidity is very low in the middle. Bees get thirsty, and it's very high on the outside of the cluster. So the bees in the mantle out here are unable to evaporate water away very well. It's really the bees in the middle that will do any evaporation of excess water. These bees already have all the water that they can handle on the outside. Any standing water on the bottom board is usually a kiss of death to a colony. So you always want to make sure that your colonies or your hives are tipped slightly forward so there's no standing water inside. But too little water, the colonies get too thirsty. So you want to try to get the balance of water in the colony. And people don't realize, even when it's raining, bees get very thirsty because they don't have any water foragers that can fly out to bring back water, especially if they're wearing any brood. They get very, very thirsty. So if you get any kind of brood break or flight weather during the winter, you'll see the bees come out oftentimes and hit the water source, desperate for water because they're so thirsty inside. So if you have an uninsulated cover over the top of the hive, you'll see water condensing and dripping there. If you have an insulated cover, any water condenses around the perimeter, drips down the sides where the bees are able to get to it. So snow melt means inadequate top ventilation up here. So styrofoam ventilation is probably your best ventilation. It can go below the cover, on top of the cover, doesn't make any difference as long as you have it sitting up there. It does not lose its R value with moisture. So anything like straw or something like that, as it picks up moisture, it loses its insulated value. So the styrofoam does not do that. And the moisture then condenses around the side where the bees can get to it. The most important thing is this balance of total cavity space to the cluster size. So you want a good balance that the little bit of warmth that comes off this cluster warms that cavity just enough that you get your condensation in the right place. If you have too smaller cluster or too large a cavity, you start to get condensation all around and you wind up with moldy comb. So it's largely an issue of the relationship between your cluster size and the cavity, the total number of boxes that you have in the hive. So a small cluster does better in a single, a larger cluster needs a double D. And it's in minimal ventilation, the bees like. Oh, I duplicated that one. And here's, this is an interesting thing. I'm kind of backing off on this, the assumption being that you get a lot of draft coming in if you have a top and bottom vent. I ran one experiment, which I'm going to be repeating this winter, to test whether that's actually true. And what I did is I took double deep hives full of drawn comb with no bees in them and put in a 1 gallon metal paint can with an aquarium heater in each one. That duplicate a cluster here, heated that the two of them up to the same temperature, and then one of the two hives opened up the top vent and then monitored the temperature of that gallon of water. assuming that by thermosiphon, that the heat from that can of water would cause a thermosiphon, and they lose a lot of heat, and that the one in the top end one would cool down quicker. I found out that wasn't true. So I need to repeat this. Apparently, the air friction of all the combs inside slows that down. So even though this is a common belief that the top venting will chill them, I don't find necessarily that there's evidence for that. You do want this condensation so that what they call water bottle bees can suck up that water and recycle it back to the cluster. So it's all about the dew point. So these are a graph I made after some data from Owen, that you can see the temperature here and as it drops down, and that the warmer air is up here. So you get most of your condensation to the sides under the cluster. So smaller clusters have more problems with water condensation. In general, colonies underneath the snow kind of melt like a tent in front of the entrance, and they seem to breathe okay where I live. It's not a problem for me. In other areas where the snow freezes harder, people say colonies can suffocate. So we'll talk about top end again in a minute there. And bees that have too much moisture, they got to get out. As soon as it warms up enough, they fly out. You see dysentery here and dead bees in the snow. These had too much water in their guts. Also, bees infected with Nosema will tend to fly out and sacrifice themselves during the winter. But also at very cold temperatures, other bees will fly out to get water and give them enough moisture. So there may be a benefit, and this is research by Owens back in 1971, that says that this occasional flight out during the winter is helpful. Well, if you look at a temperature of an uninsulated hive down here, it drops under really cold temperature. Well, the bees from the cluster are not going to walk down all those cold combs to fly out because they would be chilled by the time they got here. So there may be an advantage to putting a midway opening right here so they can fly out if they need to defecate during the winter. And sometimes you get too many dead bees or ice. I don't know if you have that problem where you guys are at. So here's a photograph of holes here where they put a top hole in here for flight. Probably a midway hole would probably be the ideal for the colonies. And I have seen this up in Canada, Saskatchewan, where they do a midway cluster opening, and they put a wind block over it right here, so the bees can get out, but that you don't have wind blowing in onto the cluster. And again, here's another cold weather. What they did here is they pack 4 colonies side by side, and all the clusters will move to one side towards the center to share heat. Top insulation and wind block here, and then a midway entrance. This would probably be the ideal situation for our configuration for wintering bees in a cold climate during the winter, right here. So that's why I put this picture in here. Now, Nosema, this is a picture of a bee's gut tissue. Midgut tissue is a tracheal tube. Every little white oval is a Nosema spore. And understand that Nosema does not cause dysentery. Dysentery is due to water imbalance. But if they are pooping in the hive, then it can spread Nosema. I just dissected a whole bunch of bees, winter bee samples we took. We actually found very little Nosema in them, in the winter bees. Nosema is usually a problem when pollen starts coming in the springtime. Nosema can only be diagnosed with microscopy. So here's a couple of bee hairs at 400 times magnification, a couple of different pollen grains here, and these would be Nosema spores here. And if you look here, your spore count of the entrance bees spikes in springtime when you have a lot of pollen, and it drops the rest of the year. So this is from my data that I took here in the foothills here. And the more important is the number of infected bees out of 10. And what you can see with the spore counts are high, but the number of infected bees, if you take your forager counts, they scare you. So you want to look at your bees, and they were fairly low in the winter. They spiked in the springtime when they had a lot of pollen. They drop off to nothing in August when there's no pollen coming in. So this is your prevalence. How many bees out of 10 were infected with Nosema? And this is interesting. A lot of people are concerned about Nosema during the winter, but these are all studies done from cold areas, most of them in Canada. And they all say there's no correlation between Nosema ceranae and winter losses. So I'm not sure how concerned people should be about Nosema during the winter. And again, I'm not going to go over this thing. Again, not showing that Nosema was a problem during the winter. So let's go back to the winter cluster. And during the winter, anybody who's inspected colonies during the winter finds out that there is midwinter brood rearing. It's usually November is the least amount of brood, and then the bees start rearing a little bit of brood again. They may actually rear enough brood to increase the number of bees, adult bees in the colony, and do that over the winter. So this is from Lloyd Harris when he looked at his data. 17 of the 21 colonies contain pupae when they're placed into winter quarters on December 5th, despite temperatures being down to -11 to -26°C. So you're talking about fairly cold temperatures there, and a high proportion of these colonies contain brood right in the middle of winter. What he said was the amount of brood reared during the winter was almost equal to the number of bees that had died during the winter. If colonies are to maintain their numbers during winter, they must rear some brood. If they do not, their numbers in March will only be about half of what they were in December. So this winter brood rearing is often overlooked. And the problem I have where I live is we don't have any bee bread reserves in the fall, because we don't have a fall pollen flow. So the question, there may be another reason that they rear brood during the winter, and it may be to avoid dysentery. So Mavis and Umhold say, hey, when these bees have too much moisture in their guts, they're able to absorb that moisture out of their guts and put it into brood food and eliminate that moisture from their bodies simply by rearing brood. So if they have enough bee bread in the combs to rear round or brood in the winter, during the winter, they can dump that moisture that's in their guts, convert it into nutritious jelly, but get it out of their bodies via the mouth rather than via the anus, and avoid dysentery. We need more research on that. And if they do that winter brood rearing, it also will cause the colony to expand, and the center cluster will expand out and warm the whole cluster up for a little while. So that's this figure about that, okay. So key thing is very interesting study with Henry Perker. What he found is where you have your bees in a winter shed, that if he gave them extra humidity, that they actually engaged in brood rearing and were healthier during the winter. So that we still have a lot to learn about this, the importance of humidity within the winter cluster. It's not necessarily a bad thing. So they do need protein during the winter for body maintenance, and a fair amount if they're going to rear brood. And that's why when you look at beekeeping in the Midwest, they talk about bringing your colonies into the winter with 5 frames of bee bread. Well, we'll never see that where I live in California. That would be, but that allows those bees to do that midwinter brood rearing. So going to winter with some bee bread is a good thing for the colonies. So since we lack stored bee bread, we feed pollen sub. So here we're taking our bees in winter, so this would be in early February, down to the almond orchards. And a lot of the growers want us to drop the bees in before the almond trees come into bloom. So it's just a desert down there. we're taking our bees off of a nectar and pollen flow up in the foothills where it's warmer. And when we drop them off, we don't want them to stop that brood rearing. So we'll give them 2.5 pounds of pollen every hive, just so that they have something to eat during that week before these trees come into bloom. And here's a picture of bees during the winter with pollen sub in all their guts in December that we had fed. I'm going to be starting a trial here pretty soon where I'm going to feed fluorescent tag pollen sub in the fall here and see how long they hold that inside their guts during the winter. Then the first pollen starts from the trees in the early spring. In our area, it's the alder trees along the creeks that bloom. Bees bring the alder pollen and they just ramp up brood rearing and they start going again. So this is fresh alder pollen coming in. Beautiful brood right here. They'll rear a few huge frames of brood just on this alder pollen in January. Then we get the spring turnover. So these winter bees, which have had a long life here, they start rearing brood, but 3 weeks later that brood emerges and those young bees push these nurses now that were winter bees off the combs. They start foraging and bingo, they die very, very quickly then. So it's the being pushed off the combs and beginning flight that causes them to die off. The problem is happening that your amount of brood is going up in the hive and your amount of adult bees is going down. So what you can see here, this dotted line is the amount of eggs, larvae, and pupae in the hive. And this is the amount of adult bees. And you can see at this spring turnover here, you can have twice as many bees as eggs, larvae, and pupae as you have as adults. So it's very, very tenuous situation for them at that time. So very critical to get this first round of brood off their replacements before these guys die of old age. And then we get unexpected snows in the spring. And that can cause starvation because these colonies have already started rearing brood, burning through their stores. And you get starvation. And this is usually preventable by just hefting your colonies and looking for the light ones. And then either stealing honey from the heavy colonies or giving them either a heavy sugar syrup or a fondant or granulated sugar, just something to give them some sugar. And this is the way my sons grew up. If we get snow in the late winter or spring after they start building up, we're out there in our foul weather gear, feeding our hives and taking care of them. Pollen sub can really help if on that spring buildup if there's no foraging at that time. Get them through that spring turnover, and here comes the wildflowers, and this is what we all dream about. And that's it. Quick summary of wintering. I'm wide open for questions right now.
All right, thanks, Randy. Anybody got some burning questions? Hey, I've got a question. Every once in a while up here, we'll hear of people overwintering in a single deep.
Yeah.
Is that just luck or
well, they do that. They do that in Canada, but they feed that deep. So it's just solid honey. They just feed sugar syrup till they can't hold anymore. And they do okay. You have to watch them in the springtime and make sure they don't run out. So with a smaller cluster, it works just fine. With the larger cluster, you got to make sure that they don't run out of honey.
Okay. So through the winter time, it's probably more, as far as the volume to heat up, it's more efficient that way, with just making sure in the spring they get enough.
Yeah, with a small cluster. Now, if you have a big cluster, we're almond pollinators, so we like to go into the fall with a decent sized cluster. So we're madly feeding them right now to get them to come up to a decent cluster size, because we've had a long dearth all late summer. So we like to go in with plenty of honey up above. The colonies that starve in almonds in the orchard, if we get rain, are your biggest, strongest colonies. So they're in double deeps. So we like to take them in with a fairly good amount of honey on them, because almond pollination is still happening in winter. It's not super cold, but it's still winter conditions for the bees, similar like you guys get with lots of rain.
Okay.
Yeah, so starvation doesn't normally happen during the winter. It happens in the late winter, early spring after they've initiated brood rearing in earnest.
Yeah.
Randy, Gordon Cromwell, I have a question. Do you find there, or do you know that the winter bees, not the winter bees, but the mantle bees rather, when they're moving inward, are they doing that based on temperature to improve their body and their enzymes and everything, or are they doing that to get food? Are they getting any food when they're in the?
I haven't seen any research on that whatsoever, and it just amazes me. This is wintering is such a big subject that I haven't seen anybody doing the work. Very few studies where they've even marked them to track their movements or anything. So that's a big open question. How do they get the food? There's other insects that can survive cold weather, but they need to warm up from time to time to allow their enzymes to work, because enzymes are very temperature dependent, and then they can go back to cold again. So my educated guess is that honeybees probably do the same thing.
Thank you.
So I have a question about the moisture imbalance in the hive. So say you see that you're in the spring, that you have dysentery, and you can obviously check and see if it's Nosema, but if it's a moisture imbalance, is there anything that a beekeeper can do to intercede or help?
I don't know if the beekeeper has much they can do, because it's generally from appears to be from a smaller cluster and balance in cluster size to cavity size. And that's a good question. I haven't been asked that one, what a beekeeper could actually do on the moisture imbalance. What the bees need to do, they need to fly out and poop.
Right.
But there's not much you can do about the weather. So no, you know what? I wish I could answer that question, but I can't.
Okay. Thank you.
Anyone else have questions?
Randy, when you're feeding your pollen sub in the wintertime, is that a higher carbohydrate concentrate, or is it more what we would consider springtime with the higher protein content?
We do the same thing now. We don't feed pollen sub in the middle of winter, but we have a very short winter where I live. It's only about a month long as far as the bees shutting down. So we feed pollen sub up until usually around the 1st of November, when they go into their winter cluster. I have friends at lower elevation that they do feed all winter, and they grow huge colonies over winter, but they're down below where it snows. And then we start again in January, which technically is still winter here, but it's generally warmed up enough that some flowers will be blooming. So if it's sunny enough for the bees to forage in January, we don't bother feeding them any pollen sub. But if it rains when the alders are blooming, then we hit them with pollen sub. And pollen sub typically is about 50% sugar in it, so they seem to do just fine on that.
So you don't differentiate between the so-called winter patties and regular patties?
No, because we have a short winter. The winter patties are only for people who haven't left enough honey for the bees. So they put a little bit of protein in those winter patties just to give them some protein. But feeding during the winter is only necessary if you haven't left enough honey for them.
Okay, thank you.
You bet.
Yeah, Randy. Yeah, years ago, high fructose corn syrup 5 was the big thing. Now it seems to be sugar was the big benefit now. So what's your words on that?
Boy, you want to argue all night right there. I've seen there's beekeepers that swear about invert sugar. The 55 did seem to have problems. So typically what 55 means that 55% fructose and 45% glucose. So most commercial beekeepers use one of the blends. So like the Man Lake Pro Suite is 50% cane sugar and 50% high fructose corn syrup. So the bees get a combination of the sucrose, the fructose, and the glucose. Bees appear to be stimulated most by the sucrose if you want them to rear brood, and seem to winter well on the fructose and glucose, which tends not to crystallize. So honey's good, the fructose and glucose. But man, I'll tell you right now, anybody who tells you that one is it's the best for this or that, it's going to have somebody else going to be telling you just the opposite. So I don't even try.
Okay, thank you.
You bet.
Anyone else have questions?
But that's all really good questions, guys.
Anybody?
I think we ran out of questions. Well,
Anybody at home have questions?
I think we're gonna let you go to sleep, Randy.
Oh, time for dinner, actually. Been
Oh, okay.
working on an article all night. I've been doing some really interesting work with robbing screens, testing them out and seeing exactly how they work, and testing out different models, how well they work. So
Testing them against other bees, robbing bees out, or testing them against yellow jackets, because we're having a heck of a time with yellow jackets this fall.
yeah, I imagine it would work similar to the yellow jackets, and I've heard good things, but I haven't had enough yellow jackets for me to test it. But I've heard that they are effective against yellow jackets. But
You need to come here
oh yeah,
to get
hey,
your yellow jackets.
hey, somebody up there wants to run some tests. I've got a bunch of really nice, high quality stainless steel robbing screens. I'll send you some up if you want to get some data for me on testing them for yellow jackets. I've been trying to find somebody to test them for me.
Well, how much longer are they gonna be though? Yeah, I don't know if it's enough time. Are you
Oh
gonna?
yeah, no, I'm talking about next year.
Yeah, next year.
Next year, give me a call and I'll ship you up some robbing screens for you to test out on the yellow jackets.
Oh, cool.
Yeah, but
Yeah.
I give you a heads up here. They are very effective at confusing bees. And what we did is we went into colonies and glued steel little round discs on the backs of 100 bees, guard bees. We got bees on the outside of the cluster that came out to investigate us. We'd pick them up and glue the discs on. Guard bees typically guard for about a day or two, and then they start flying. So we wanted bees, so their first flight would have been out through the robbing guard. So we marked them and then put a robbing guard on the front of the hive, and then put magnetic traps on the entrances of other hives in the vicinity, and in an apiary, and then saw how many bees can't figure out how to get back into the hive. That they exit their first flight through the robbing guard, but can't figure out how to get back in, give up, and they drift to another colony. The first one we did, 30% of those 100 bees went to the colony next door, one on either side. We did it, replicated it 5 more times on different hives, 2 different yards. And on average, 25% of the bees don't make it back. They drift to another hive. This is really interesting implications because that should happen every day. We didn't test it day after day, but if the bees on their first flight drift, you're going to have bees taking their first flight every single day. So this is very interesting findings, the possible impact of putting robbing guards on.
Hey,
That
Randy,
says a lot for. Oh,
Go
go
ahead.
ahead, Gordon.
I just can't let it go without asking you to comment on the concept of the condensing hive when, the hive IQ and that sort of a concept, and some of the talks that we've heard. Most of us use an upper entrance. We just noticed that our bees are using most of that through the wintertime. So the whole concept of the condensing hive is.
Yeah, and that's why I'm questioning. I assumed in the experiment I did that the top entrance would cause them to chill, and it doesn't, because people aren't taking into account the friction, air friction in there. The other thing, I've done the calculations on for thermosiphoning, and you have to look at the air column and the difference in density. And I checked that out, and there's not that much pressure difference to drive that. It's not like a wood stove where you have a very high temperature in the chimney and a tall chimney. In a beehive, there's not that much temperature difference. So really, there's not actually much ventilation going out of the top of the hive, which also means there's not much water going out the top of the hive either. Most of the air in the top of the hive will be very high in water vapor. I've run some tests, and it runs about 99% relative humidity all the time at the top, because water vapor is less dense than air, so it rises. People have a mistake thinking that moist air is more dense than dry air. It's just the opposite. The more moisture in air, the less dense it is. So it does rise to the top of the hive. That the upper flight entrance is probably important. So that's what I'm saying. I don't have hard data, but that where I've seen the people with the midway flight entrances, that seems to work well. As far as the whole condensing hive, I got a thermal camera this winter, and we dropped down to 15 degrees Fahrenheit. It's about as cold as we ever get right here. I happened to have a hive outside that I had built that had glass sides on it, so I could observe the bees and shoot them with a thermal camera. I could open it up and do a thermal shot of them. And I had thin insulation, an R4 insulation, which is not much insulation on the outside. And at 15 degrees, when I opened that up, those bees were right against that glass as happy can be, just walking around. They weren't even clustered. So that was the only R4 insulation, that low value right there. So it makes me question just how much insulation you really want to put around a hive if you're not in an area like an Arctic area, like Etienne up in the Yukon. Yeah, he's going to want more insulation. But where I'm at, or where you guys are at, you don't get that cold. The problem with too much insulation is in the springtime, the bees don't get the cue that are starting to warm up, and they can start ramping up for early brood rearing, so they can build up in time for the first honey flow. So that can be a problem. Another fallacy I'm hearing is the thing about thermal mass in around the cluster too, and I don't see that at all being a benefit to the bees. The bees want to control their own environment, the temperature there. If you have a bunch of thermal mass around them and it's wintertime, that thermal mass is just like, trying to live in an igloo with, cold around you all the time. You're better off having less insulation and being able to, or having some insulation, but not much thermal mass. So, how cold does it get in your area during the winter?
Oh, we'll once in a while we'll get down into the upper teens for a week or so, but most of the time the lowest we get will be, freezing or down into the high 20s for not very long.
So you're the same as my area. We're right around the exact same temperature range. We don't have side insulation. We don't even have top insulation on our hives. But I do know that, just because I haven't figured out how to do that and get the bees to fit on the truck for almond pollination. So if I were a hobbyist, I would have an inch of styrofoam on top of my hives, at least during the winter, maybe all year long. But this hive that my experimental hive, where I just have R4 value, I'm using acoustic soundboard to give them a thin layer of insulation. Boy, the bees at 15 degrees, they were just happy as can be.
Okay. All right, thanks.
You bet.
Any other questions from the room? From home, anybody?
You to specify what you mean by thermal mass.
Thermal mass is something that holds the heat. So like if you have a a great big chunk of steel, it's not going to change its temperature very fast because it has thermal mass. It doesn't, something that holds its heat. So water has very, very high thermal mass. Honey has a high thermal mass. It's hard to warm it or hard to cool it. So within the cluster, any honey within the cluster is good, because that means if it's warm, that honey is warm, and you get a sudden cold snap at night, that honey has thermal mass and give off to the bees and kind of equalize things out. But because bees live in trees, people are saying, oh, wow, all that thermal mass of all that wood above the hive has got to be good for the bees because you're not going to have much temperature change. Well, that means if your average temperature during the winter is freezing, that the bees are always going to have that freezing thermal mass that's going to be actually sucking heat away from them continually. Whereas really what they need is just insulation to keep the heat from moving. So people get insulation and thermal mass, the benefit mixed up.
Okay, just wanted you to explain it. Thank you.
Yeah. There's a lot of, I'm not a physicist, so I've had to investigate all this stuff, figure out what the hell the reality check is, because people throw around all these words and people go, oh yeah, that must be a good idea. But then you look at the actual physics of it, you go, no, you're not understanding.
So I have a question for you, based upon what you were just talking about for R value. At the WASBA conference, we were, because the speaker was from a cold environment, also was talking about trying to maintain an R value of 4. Would you then from what you just said with the hive that you are observing, that they were happy as can be at 15 degrees Celsius?
No, 50 degrees Fahrenheit.
Oh, would you advocate that as we start to warm up in the late winter, that some of that insulation that we've done, we should remove to better stimulate the bees towards their brood cycle?
Yeah, so like Mike Palmer in Vermont, where it gets to way below 0, he wraps his hives only with a layer of tar paper. That blocks the wind and allows the hives to absorb some sun on warm days in the winter, and they build up. He doesn't put any side insulation on his colonies. He's adamant about not putting side insulation on his colonies. He puts heavy insulation at the top and just tar paper around them.
Thank you.
You bet.
Anybody else? Thank you, Randy. Really appreciate
So
you
let
talking with
me
us.
tell you one last point. Okay, I told you that the bees, they take their admins down to around 50 degrees Fahrenheit. That means at a temperature of 50 degrees Fahrenheit, there is no heat loss from a hive at all. To have heat loss, you have to have a difference in temperature. So since they drop their admins down intentionally to 50 degrees, that means at 50 degrees, you don't need any insulation whatsoever. There's no heat loss because that's the temperature that they winter best at right there. So that might tell you something.
Yeah, never thought about the mantle temperature. You're always thinking about the inside.
Forget the core temperature, it's the mantle temperature.
Yeah. Interesting.
Yeah. Yeah, I'm actually looking to buy a big chest freezer I can put a couple of hives into, so I can do controlled experiments. Because I'm, we don't have much winter here, but I'm fascinated. People ask me all the time about winter, and so since I don't have a cold enough winter, I'm going to create one in the chest freezer so I can run some of these experiments. All right, guys, it's been great.
All right.
I'm gonna get some dinner. You guys have a great night.
Yep. All right. Good.
You bet.
Thank you.
Okay. Hope to send them a few thousand yellow jackets next year. Yeah.